All right, so today we're going to be talking about properties of logarithms. This is section 10.3. So just as a reminder that logarithms are the inverse of exponential functions. All right, so to get started, let's just go right into our properties. We'll review with the ones we talked about yesterday. One of the properties was the translation property. Translation property said that if you have a to an x power is equal to n, you could write it using logarithms as log base a of n is equal to x. You could just use the crisscross method to confirm that. And of course, you can go back and forth. Another property we talked about was called the inverse property. Now with the inverse property, we said that if you have a to the log base a of x power, they actually cancel and you just get x. Similarly, if you have log base a of a to the x, then those cancel and you just get x. And we'll be seeing some more examples like that today. Third property was the property of equality. And the property of equality said that if you have a log with the same base equal to a log with another base, those logs actually cancel and you just get the arguments are equal. Now as long as your arguments aren't 0 and as long as they're greater than 0, then it'll work. Remember, your arguments can't be negative. So some new properties for us today. Start with the power property. Power property is pretty cool. It says that if you have a number in front of a logarithm, it's the same thing as raising that argument to that power. Similarly, if you have a power, if you have an argument to a power, you could bring that down and it's the same thing as multiplying. So for example, if I asked you what's the log base 2 of log base 3 of 3 to the third, say something like that. What you could do is you could bring this 2 up. And you could say that this is the same thing as log base 3 of 3 to the second. And you could see that these are the same using the property of the inverse property. The answer here would just be 2. That's just an example. We also have something called the product property. Product property says if you are taking a log, base b, of 2 terms being multiplied together, you could also write that out as the log of the first plus the log base b of the second. So sometimes it's a good idea to combine logarithms, so to take these two with a plus sign and write it as 1. And sometimes it's a good idea to write them as 1 as separate. So we'll see examples later today with that. So if I asked you what's the log base 3 of 2 plus the log base 3 of 4, you could tell me that that's the same thing as just saying the log base 3 of 8. 2 times 4. Well, if that's the product property, we also have a quotient property. Quotient property says that if you're dividing 2 arguments, that's the same thing as log base b of the first, or of the top, minus log base b of the denominator. So if I asked you what's the log base 3 of 8 minus the log base 3 of 2, that's the same thing as the log base 3 of 8 over 2, which is log base 3 of 4. It's the quotient property. So we have, and that's all the properties. We have the ones from yesterday, translation, inverse equality. And we have 3 new ones today. So let me show you what we're going to be working on today. It's actually pretty fun. It's kind of like a math jigsaw puzzle. So what it is, let me show you. Given log base 12 of 8 is about 0.8368, and log base 12 of 10 is about 0.9226, find log base 12 of 80. So what you have to do is, at this point we can't type logs into our calculator. So you have to use the base and either argument to figure out how do you come up with 80. Well, 80 is 8 times 10, right? So this is log base 12 of 8 times 10. Well, using the product property, this is the log base 12 of 8 plus the log base 12 of 10. And I told you what the log base 12 of 8 was, and I told you what the log base 12 of 10 was. So if you just type that into the calculator, that's just basic arithmetic, you would get 1.7594. That's what we're doing here. So you have to try to figure out how can I get 80 from the base and the 2 arguments. Okay, let me give you another one. How about this? What about if I asked you to find log base 12 of 96? So you could pause the video and try to figure out how do you get 12 from 8, 10, and 12. Well, 96 is the same thing as 8 times 12. So again, we have a product property, log base 12 of 8 plus the log base 12 of 12. Log base 12 of 8, I told you, was 0.8368. Log base 12 of 12, well, that's an inverse property. You don't just get nothing. Remember, it's the power, right? So that's 1. So the answer for this would be 1.8368. These are kind of fun. I hope you enjoy doing these. Let's kind of amp it up a notch. What about the log base 12 of 5/4? So you have to figure out how can you get 5/4 from 12, 8, and 10. Well, if you think about it, 5/4 is the same thing as 10 divided by 8. It's just simplified. So using the quotient property, this is log base 12 of 10 minus the log base 12 of 8. We know the log base 12 of 10 is 0.9226. Log base 12 of 8 is 0.8368. So if you type this into your calculator, you would get 0.0858. Let me just make sure here. So 0.9226 minus 0.8368. Yeah, so that's the right answer. Okay, one more, and maybe we'll finish up with another one similar to this. What if I asked you to find the log base 12 of 144? Well, 144, you should recognize that's just 12 to the second. Well, look at that. That's an inverse property. Also the power, we could bring the 2 down and just cancel those, but either way, all you're left with is just the 2. All right. Let's try one more example. I'll give you some different numbers. What if I say given log base 16 of 3 is equal to 0.3962, and log base 16 of 20 is equal to 1.0805. Find, give you 4 more, log base 16 of 5 over 64. This one's a little bit harder. You have to think about how can you get 5 over 64 from 16, 3, and 20. Well, this is the same thing as 20. So this is log base 16 of 20 over 16 to the second. Oh, wait a minute. No, that's not true. So log base 16 of, let's see here. I know that this is the same thing as 5 over 16 times 4. And let's see. That's the same thing as saying log base 16 of 5 over, let's see here, that's 4 to the third. So this one's a little bit tricky. Yeah, I can't put this up there.